inequalities. So these are pretty much like equations, except the only thing is when you multiply by a negative or divide by a negative number, then you flip the sign. Okay, but the other operations are the same. So here with A, we're adding, so here we have x less than 5, and then you have x minus 3. So basically you're subtracting 3 from both sides. So if you subtract 3 from 5, you get 2. And so that just, the sign just going to stay the same. And if you multiply by a positive number, the sign will stay the same. It will be the same. And that's what happened here. Here, you're multiplying by a negative number. So the sign flips order. So instead of being greater than or equal to, it flips to being less than or equal to. And then here, you're multiplying by a negative 1. And so again, your sign flips the direction. So instead of being less than, it becomes greater than. Okay. To just kind of illustrate why that would be the case, it's like inequalities are determined by position on the number line. By position on the number line. So numbers that are to the left are smaller, and numbers to the right are greater. Okay, so if you had like, let's say you had like 1 and 5. Okay, so 1 is less than 5. Okay, now technically this is also true, although it's kind of confusing. Those are both true statements. But if you take the negative 1 and negative 5, then it goes the other way, because here you have, because 0 is going to be there, and then negative 1 is here, going to be negative 5 is going to be over there. So negative 1 is to the right of negative 5. Okay, and then also technically you would write this also. This is also true, although it's kind of confusing. But when we have values of x, then it makes more sense. Okay. Okay, now here, this is a more complicated thing. Now notice what we said before is if you multiply by a negative or divide by a negative, then you have to flip the order of the sign. If you divide by something that you don't know is negative or positive, then that's a problem. Okay, you want to avoid doing that. And so that means when you're dealing with something like this, it's a bit more complicated, but here they give you the method of doing it. Okay, and so let's go ahead and go through this. And you can follow along in the Webassign. To solve the inequality, we're supposed to observe that negative 3 and 6. So if you take the numerator and set that equal to 0, you get negative 3. Okay, and that's where that comes from. If you take the denominator and set that equal to 0, you get 6, and that's where that 6 comes from. Okay, and then these numbers divide the real line into 3 intervals. So you have, so if here's your number line right here. Let me draw a number line down below here. Then it's divided into 3 intervals based on these two numbers, negative 3 and 6. Negative 3 is the smaller one, so that will go here. And 6 is the larger one, so that goes there. Okay, that's divided up into 3 regions. Okay, so from negative infinity to negative 3, and then negative 3 to 6, and then 6 to infinity. Okay, so it's based on the zeros of the numerator, zeros of the denominator. That's what we got. Okay, now let me note here that it's also important that you have a 0 here. And the reason for that is if you have a number, we'll call it y in this case, if y is greater than 0, that means it's positive. And y less than 0, that means that number is negative. Okay, so positive means greater than 0, negative, less than 0 means negative. Okay, so those are what those are. Okay, now, so let's continue on. Here they split it up into the x plus 3 and the x minus 6, okay, which is what you should do when you're faced with something like this. So first of all, you look at the x plus 3. Now, you're taking a value of x and you're adding 3 to it. If x is anywhere over here, if x is less than negative 3, so like maybe it's negative 4 or maybe it's negative 7, okay, if you plug it into here, this is still going to be negative. Okay, but once you pass over into here, any value between negative 3 and 6 is going to, this expression is going to be positive. Okay, because like, let's say negative 2, for example, negative 2 plus 3, that's positive 1, so that's positive. It's also going to be positive over here. Okay, x minus 6, that's going to be negative here, and it's going to still be negative here, but it's going to be positive over here, because you're taking x and you're subtracting 6 from it. So if you're less than 6, then you're going to be negative. But if x is greater than 6, then you're going to get a positive number. Okay, and then here's where this method hopefully will start to make sense to you why we do it this way, because now we're looking at the sign of x plus 3 over x minus 6. And so on this part, on this interval, you're taking a negative number and dividing it by another negative number. So a negative number divided by a negative number, that's going to be positive. Okay, a positive number divided by a negative number, that's going to be negative. And two positives, one divided by another, is going to be positive. Okay, and right here, less than or equal to 0, that means negative or 0. Negative or 0, which means that this is what we're looking at, this region here. Okay, let's continue on. The next part says, do any of the endpoints fail to satisfy the inequality? Okay, if you're at the -3 endpoint, then this makes the numerator 0, and the whole thing's going to be 0, which is less than or equal to 0. So that one's fine. But the 6, that makes the denominator 0, and that just messes everything up. So that means that the 6 fails to satisfy the inequality, because when you plug 6 in, it's not even going to be defined. The expression's not even going to be defined. So, of course, it's not going to satisfy the inequality. Okay, and then once again here, this is the region that we're looking at, because right here, and so and -3 works, so that goes in, and also 6, but 6 doesn't work. So -3 to 6 would be the answer. Okay, any questions on that before we go to the next problem? So that was kind of like a more complicated problem, but just breaking it down. Let's do some other problems. Number 3, solve the absolute value of x is less than or equal to 5. Okay. Absolute value means that you take whatever the number is. If it's negative, you make it into the positive of that. And if it's already positive, then you keep the same number, right? So this one, it turns out the answer is -5 to 5. Because if you take the absolute value of any, you can like look at a few examples here. So So here's the number line. If you have like -4, for example, if you take the absolute value of that, you're going to get +4, which is less than 5, right? But if you're at -6, that's not going to work because the absolute value of -6 is actually +6, which is greater than 5. Okay, so if you put a -6 in here for x, this is not going to satisfy the inequality. But it will satisfy this inequality. And so this one is actually -∞ to -5 union 5 to infinity. Okay, so those are the answers to those two. With the second one, any number that's less than -5 is going to work. Because when you take the absolute value, you're going to get something greater than 5. Okay, and then likewise, any number greater than 5, you take the absolute value, it's just going to be that number, which is going to be greater than or equal to 5. The absolute value is important for calculus. So let me just write a little note right here about the absolute value. And then we'll do number 4, I'm sorry, this is number 4. Okay, so if you have an expression like that, this is the distance between x and a. Okay, so the absolute value of x minus a is the distance between x and a. And so right here, part number 4, it says the set of all points on the real line whose distance from 0 is less than 3. Okay, this is the distance between x and 3. Is that, and you want that to be less than 3, so you force it to be less than 3. Okay, and so that's why this answer is going to be the correct answer. Okay, because that simplifies down to the absolute value of x is less than 3. Okay, likewise here, this one, distance from 0, that's what that is. That's the distance from 0. You want it to be greater than 3. Okay, so that's why this is going to be the answer. Okay, if you have any questions, just speak up, okay? Okay, so number 5, if x times x plus 1 is greater than 0, does it follow that x is positive? And this is, the answer to this is no. If x is positive, then this will be greater than 0, right? But there could be negative numbers that give you this too. And the key is to find something where that's negative and that's negative. And so maybe -2 will do it. Will be an example that does it, okay? Because then you're going to have, so x is 2, that means x plus 1 is -1, right? And then x times x plus 1 is going to be -2 times -1, which is 2, which is positive, which is greater than 0. So here's a negative number, -2, that satisfies this inequality. Likewise with b, you could do the same thing with b. Maybe just have, I mean, even that's even easier, because if you took like, for part b, you don't even have to go negative. You could just say, even say x is 4, for example, and then x plus 1 is 5, and then x times x plus 1, that's going to be 4 times 5, which is 20, which is greater than 5. So here's a value that does that. So the answer is no for that one too. And there's the value. That's no. And there's a value. That's no. There's a value. An example. Okay, moving on to the next question. Here you have a set of, these are distinct numbers, -2, -1, 0, 1/2, 1, square root of 2, 2, and 4, and determine which elements of S satisfy the inequality. Okay, so we plug in, so we test the first one, and this is going to be -2 squared plus 3, which is, this is 4, that's 7. So this one doesn't. This one's no. This one doesn't satisfy the inequality because that gives you a 7 when you plug it into here. And 7 is not less than 5. If you plug a -1 in, you get 4, which is less than 5. So that's going to work. And if you plug a 0 in, then you're going to get 3, and that is less than 5, so that works. If you plug in 1/2, you get 3 and a 4th. That works, so that's less than 5. If you plug in a 1, then you get 4, just like this one, so that works. And then if you plug in √2, √2 squared is 2 plus 3 is 5. And so that's not going to work because it has to be less than 5. You can't be 5. So that one doesn't work. And then likewise, 2 and 4 don't work either because those are going to give you even bigger numbers. Okay, so the answer is all of these ones right here. Okay, so that's the answer to number 6. Okay, number 7. Yeah, any questions on that? Okay, so number 7, we have the linear inequality. Now, like I said before, you can add and subtract, and you can multiply by positive numbers. And it's just like working with an equation. But if you multiply or divide by a negative number, then you have to flip the direction of this line. Okay, so here, what we're going to do is we want to isolate an x in the middle. So we're going to subtract 1 from all 3 sides. Okay, and that gives us -10 less than -2x less than or equal to -3. Okay, now we're going to divide by -2. Okay, so that gives us a 5, that gives us an x, and that gives us 3/2. But since we're dividing by a negative number, you have to flip the direction of the signs. Now, it's customary to go from the smallest to the largest, right? And that's what we started out with right here. But here, since the direction of the inequality was flipped, then we're going from largest to smallest. So you just rewrite it this way. So rewrite it like that. And when you go from smallest to largest, then it goes right into interval notation. So since this is less than or equal to, we use a square bracket. Okay, so less than or equal to is a square bracket. Greater than or equal to is also a square bracket. Less than is a parentheses. Okay, so because this is greater than or equal to, we have this square bracket. Because this is less than, we have these parentheses here. Okay, so this should be the answer to the first, to number 7, to the first part of number 7. Okay, it'd be very helpful if you have Webassign open right now. And I will show you how to input these because there's going to be a lot of inputting. So what you want to do is you want to hit this button here and then place that at 3/2, which is right here. This requires a lot of clicking skills. So hit that and then click there. And that'll put the bracket. This is 3/2. So 3/2 is 1.5, right? Which is halfway between 1 and 2. Okay, then you want to do a parentheses. So you're going to hit this one here and at 5. Like that. And then you're going to hit this one right here, which is draw. And then just click anywhere in here, and it will create this little line segment there. Okay, that's how you input the stuff in, and that's what it's supposed to look like in the end. Okay, I'll give you guys a minute. Anybody able to do that?
Yeah, I was able to.
Okay, great. Good for you. Great. Okay, let's move on to the next exercise then.
Can I just confirm something real quick? So you said that the greater to and less than to, are the brackets, right? Or the greater or even to, that stuff, right?
Yeah, or equal to. If it's greater than or equal to, so generally, if you have less than or equal to, then that's going to be that or that, wherever it's appropriate, you know, because depending on where your x is. Okay, so if you have an x, let me be more specific. If you have that one, then it's this in this bracket. If you have that one, then it's going to be this bracket. Okay, if you have this one, then it's going to be that bracket. Then it's going to be the parentheses. And if you have this one, then it's going to be this one. In the appropriate place, okay?
Okay, perfect. Thank you.
Sure, you're welcome. Okay, so now number 8. This is getting back to what we discussed earlier when we looked at, so if you refer back to this problem right here, number 2, then we're going to do number 8 in a similar way. Okay, because you have a product here. Now, when you have something like this, it's really important to get a 0 right here, because note just a 0 here. That means that and that means positive or 0. Positive or 0. Another way of saying positive or 0 is to say non-negative, by the way. So that might come up. But anyways, let's go ahead and look at this. So you can see that if you find the zeros first, then that's -3, 7, and -4. Okay. So what I'm going to do is with these 3 numbers here, I'm going to put those on the number line, but I'm going to put down the expressions. Okay, so x plus 3 squared, x minus 7, and x plus 4. And this makes up all of this whole product right here. Okay, and now the numbers, I come over here, I put the first number, the smallest of these is the -4. So I'm going to save a little bit of space right here and then put the -4, and then I'll put the -3 because that's the next larger one, and then I'm going to put the 7. Okay, and these don't have to necessarily be up to scale. Okay. They just have to be in order. That's it. That's important thing. So now I'm going to like draw these dividing lines right here, and I'm going to look at this one right here. Well, this first one, you're going to take it and you're going to square whatever is there. So that's always just going to be positive, no matter what. Except it'll be 0 right here. So this expression will be 0 right there, which is important to get the problem correct. Okay, here x - 7. That is going to be negative up until it reaches 7, at which point it's going to be positive. So if you have a number, if this number here is greater than 7, like if it's 8, 8 - 7 is 1, which is positive. But if this number is less than 7, then you're going to be negative. Here, it changes sign right here at the -4. So that's what the sign looks like there. Okay, now down here, I'm going to take the whole thing. So I've got x plus 3 squared times x minus 7 times x plus 4. Okay, now when you're less than -4, this first one is positive, the second one is negative, and the third one's going to be negative. So that's going to be positive. Okay, so you have two positives. They cancel and become a negative, right? I'm sorry. I said that exactly opposite of what I meant to say. You have two negatives, they cancel them. When you multiply them, they cancel and become a positive, right? Okay, so that's positive there. This is negative when you multiply those three together, and that's negative, and this is positive. Okay, so odd number of negatives means negative. Even number of negatives means positive. Okay, now here, we want positive or 0. Okay, so there's positive and there's positive. Okay, and 0 is here, here, and here. So, because it's greater than or equal to 0. So positive is there in those two intervals there, and it's 0 here, here, and here. And so either you qualify for being a solution, x qualifies to be a solution if it's positive or 0. Okay, so that means that the answer is going to be negative infinity, so to -4, including the -4. And then -3 gets included. And then from 7 to infinity, including the 7. Okay, so that's going to be the answer there to that one. It looks like the very last answer in that part is the correct one. And then the next one is to graph it. The next part is to graph it. So at -4, you want to put the bracket. Actually, it's multiple choice, so just look at that. Another thing that, let me go back to this previous problem. And here, another way of doing it is just doing the solid circle. And then open circles for these ones. That's another way that people do to denote whether you're including that point or not. Solid circles, and then open circle means you don't include the point. And so I'm looking at the multiple choice, and it has the solid circle thing. So that's what I'm. So that's why. Oh dang! Now I can't erase it. Uh-oh. That's why I'm in solid circle, and then all of this filled in, and then at -3, you've got a solid circle, and then at 7, you have a circle, and this is all filled in right here. So basically, just excluding here and here. Okay. Any questions on that part? Okay, let's move on to number 9. Okay, here, this is not 0. Okay, which is a problem because there's no, like, if it's greater than 0, it's positive. But you have something greater than 5, then you don't have that positive negative kind of thing. You know, you're just like, oh, it's just greater than 5. So we need a 0 there in order to apply what we just did in the previous problem. And so what you do is you subtract this 5 to the other side, like that, and there you have a 0 now. Okay, but now this is not a product. It's not just a straight product. So you need to like manipulate this into a straight product, and the way to do that is get a common denominator, and those aren't 5s. Get a common denominator by multiplying this term by x plus 1 over x plus 1. And now you can combine the denominators, but you have 5x minus 5 all over x plus 1. And so you have negative 4x minus 5 less than 0. Okay, so now you have less than 0. Let me go one more step, and I will factor out a negative 1 like that. Okay, now if you set 4x plus 5 equal to 0, that's going to give you negative 5/4. And if you set x plus 1 equal to 0, that gives you negative 1. Okay, so those are the points that are going to go on your number line. Okay, so negative 5/4 and negative 1. Those are going to be the points on your number line. Then here you have negative 1, you have 4x plus 5, and you have x plus 1. Okay, so those are, you could also just leave it as negative 4x minus 5. That's a bit more confusing. But pulling this out as a negative 1 is fine too, because you just say that's negative there, negative there, negative there. This is always negative no matter what x is. Okay, this one is negative there, but then it flips right here. This is negative there and there. It flips right here. And this is, so the product, it's a quotient product, so negative 1, 4x plus 5, and x plus 1. It's negative there, positive there, and negative there. Okay. But here, so I just copied that, I forgot to write that down. This means negative. So that means that this one and this one are what you're after. And the endpoints are not going to be included because it can't be 0. And even if it were greater, if it was less than or equal to 0, then you wouldn't include the negative 1 either, because that would give you a 0 in the denominator, which doesn't work. But this one would be included. The negative 5/4 would be included. But anyway, it's not there, so it doesn't matter. Wait a minute, I messed up. This is greater than, and I put a negative, I put less than. What's up with that? Okay, greater than, greater than, greater than, greater than. Greater than. Okay, so that means positive. Let me do a different color. Okay, so the red color is wrong. The red color is wrong. All right, let me try to erase it. Hang on, I'm going to try not to make mistakes in the future. Okay, so I'll fix everything so it doesn't even look like I made a mistake. Okay. So positive means it is this one, this interval here, excluding the endpoints. So we're going from -5/4 to -1, like that. And there is you have to graph the solution set. So let me see here. Let's see, go to where there's a -2, and then there's a -1 right there, right? And then there's these halfway points like that. Okay, so this right here is -5/4. So put the parentheses here for this one. For that's that parenthesis, and then this parenthesis is right here. And then you fill this part in. That kind of looks like a little TIE fighter. Okay, so any questions on that before I move on to the next? Okay, 2 more problems to go. And this is absolute value inequalities. And let me show you how to handle these. Okay, so you have absolute value less than or equal to some positive number. So it's important that this is a positive number right here. Because if it's negative, then you're going to do it differently. That's also positive. Okay. So let me show you how to handle. There's this one, and then there's this problem here. Let me show you how to handle each one. So if it's less than or less than or equal to, then the way that you handle it is you drop the absolute values, but you tack a -4 over here, like that. If it's like this, then you do this inequality here, or you just drop it. So you drop it and put that one here, but this one you drop it, but then you flip this sign and put a -4. Okay, so let me think. How can I explain this? Why this is the case? Remember, the absolute value makes it positive, right? So now, if what's inside here is less than is like, let's say that 3x plus 2 is -5. When you take the absolute value, that's going to be 5, which is not going to satisfy the inequality. Okay, but if it's anything between -4 and 4, when you take the absolute value, it will satisfy the inequality. Okay, so likewise down here, if this quantity in here is less than -4, so let's say it's -5, for example, when you take the absolute value, it's going to be 5, which is going to be greater than 4, greater than or equal to 4. So if it's like 5, if this is -5 in here, absolute value is 5 and will work. So all these values will work in this, but as well as these two. Okay. So up here, it's a double inequality or whatever. Let's subtract 2 from all 3 sides. That gives you -6, and then a 2. And then divide by 3. And so that's going to give you the answer from -2 to 2/3. And for the number line answer, you come to -2. And then, let's see, the number line has it skips numbers. So here's 0. And then here's +2 over here, and then it has got these little hash marks here. This is -1, this is +1. So 2/3 is going to be about right there, and -2 is going to be there. And so then you just fill that in there. Okay, and then for this one, you do each of these separately. So here you add 1 to both sides. So x less than or equal to -1. And then here, add 1 to both sides here. And then divide by 3. And since 3 is a positive number, that doesn't flip the sign. Okay, so here, this one is going to be -infinity to -1, including the -1. And then this one's going to be 5/3 to infinity, including the 5/3. Okay, so that's going to be the answer to that one. To graph it on the number line, at -1, you put a bracket going this way, and then fill that in. And then at 5/3, let's see here, you have 1 there, and then you've got a little hash mark, a bigger hash mark, and you have a bigger hash mark at 2. So 5/3 is 1 and 2/3. So this is 1. So you're going to go, so basically you want to go from here to here. You want to look at where 2/3 is, and it's about right there. So put it right there. And then fill that in. Okay, great. Are there any questions about anything? Oh, wait, there's more problems. Oops. Okay, so now number 12. So these 2 problems go back to what we said before. X minus a, the absolute x is the distance between x and a. Okay, so you can use that concept to answer these questions. So number 12, a phrase that describes a set of real numbers is given. All real numbers x at most 7 units from 3. Okay, so it's talking about the distance between x and 3. Okay, at most 7 units from 3. So it's talking about the distance between x and 3. So that's the absolute value of x minus 3. And you want it at most 7. That means it's less than or equal to 7. So, okay, so that would be the answer to that one. And then here they have a graph. A set of real numbers is graphed. Find an inequality involving absolute that describes the set. Okay, so here in the middle, we've got this -2 in the middle. And so you're looking at a distance between x and -2, which would be this. So x plus 2 is the distance between x and -2. And you just force that to be greater than 1. So the distance, this distance is 1, from -2 to -1 is 1. That's 1. This distance here is also 1. And so if you force it to be greater than 1, you're going to get all these points and all those points and exclude these. You exclude -3 and -1.